Morning, sir.
Good morning. So we have seen some concepts of regression in the previous class. Right? And never ever forget that the four major applications of machine learning are classification, regression, association, and clustering. If you are doing some projects, 95% of the time your work will be under any one of these categories. Right? So for classification, we have many algorithms. For regression, we have many algorithms. For association, we have many algorithms. For the clustering also, we have many algorithms. But which algorithm should you choose? That is where we need to pay more attention to, because some algorithm is suitable for some and some algorithm is suitable for other. So all those introductory concepts we saw in the first two units. So today we will go into the specific algorithm which is called as decision trees, one of the basic machine learning algorithm. If you are a machine learning engineer, then definitely you must know about this decision tree algorithm. And this decision tree algorithm is suitable for both classification and regression. Our unit title is regression, and in the last class also we saw about regression concepts. But this decision tree can be also used for classification. I hope you must be knowing what is meant by classification and what is meant by regression. Classification means saying that this belongs to this class or not. Say, for example, it's a dog or a cat. But when you go for a regression application, it will be a mathematical equation, mathematical values will be there, and your output will be in the form of a number. Output will be form of a. Let me share my screen. Is my screen visible?
Yes, sir.
So the algorithm or the method or the procedure which we are going to see today is the decision trees. So as you know that like a tree, right? All of you must have studied about trees in your smaller classes, maybe in your first standard or second standard. You will have root, you will have stem, you will have branches, you will have leaves, you will have fruits, flowers, and all those things, right? So this concept of tree has attracted many engineers in this machine learning area, and they thought, can we do something on this concept of tree for our machine learning application? Specifically, this decision tree, the concept of tree, is used for both classification and regression applications. But we are going to focus it on the regression perception. So in decision analysis, right, it is all about making a decision. Say, for example, a tree structure is there. A tree structure is there, which is a conventional one. But if I say that I am going to make the tree for making some decision, whether this tree is going to give me a good fruit or not, or whether this tree is going to wither or not, right? I'm going to make a decision. So in our applications also, we are going to make a decision. Maybe in classification, we are going to ask whether it is a dog or a cat, or in regression, we may ask what is the price of the house. So before this word called as tree, I'm going to add this concept of decision. That's why we call this as a decision tree. So decision analysis or any classification or regression applications, a decision tree can be used to visually represent decisions, right? Visually means you can see. You can see. Normally, we go for algorithms which are mathematical in nature and the internal process are mostly hidden. Say, for example, neural networks, we call it as a black box because we do not know what's the process going on internally. But when you go for a decision tree machine learning approach, you can see visually because the tree branching structures can be seen visually, and your decision making process also is much more easier. As the name goes, it uses a tree like model for decision making, right? Whether it is classification or. So now you will wonder how an algorithm can be represented as a tree, right? How we are going to relate our machine learning with the concept of a tree, right? So we will take a small example. First, I will give you an example. Then I will go into the theoretical and algorithmic concepts. Right? Let us consider a very basic example that uses Titanic dataset. Right? This is already available in Wikipedia. If you want, you can make use of that for your project work also. So what is there in the Titanic dataset? I hope all of you must have known about the Titanic ship. Titanic dataset for predicting whether a passenger will survive or not. They have the complete list, right? Whether they have a complete list, and based on the actual cases, they have the target also. Right? Now they are checking whether this model, when they develop a model for such type of disaster situations, can this be applicable for any air travel or any other ship travel, which may face such uh, tragic situations, set for predicting whether a passenger will survive or not. So first thing is you need to have the features. As I told you, your data cannot be directly fed because it may be in the form of a text. Never ever forget this. It may be in the form of a text. It may be in the form of a video, audio, image, graphics, or animation, or whatever it may be. It cannot be given as input as such. You need to extract some features, specific characteristic features. Right? So for that, this data set, which is available in Wikipedia, they have taken gender, age, and number of spouses or children along, whether you are a single person traveling or whether you are with your wife or husband or children. If it is a children, whether they have any siblings, sisters or brother, right? They have that data chart. So based on this, we can go for developing a model. Right? So a normal decision tree will look like this. My objective is, right? My objective is whether the patient is, sorry, whether the person is, uh, can have a probability of a survival or a death, right? Whether he has died or whether he can survive. So my condition now for this decision tree is classification, not regression, because I am going to say whether this or this. So all such applications can come under the category of classification, but nevertheless, you can also make use of this structure for your regression applications also. So what are the features we have chosen here? Gender, age, and number of spouses or children, right? Gender, male or female. Then we have the age, right? 0 to you can have till 60 or 70 or whatever it may be, right? Number of siblings or spouses, persons accompanying you, right? So with that data, we have framed a sample decision tree. So the first question, the first feature we have asked is, is he a male or a female, right? So a tree is there, a tree is there. So from this feature, male or female, we are going to start the tree or grow the tree. Or in other words, you can say that normally the root will be in the bottom portion in the real-time situation. But when you go for our decision tree-based machine learning, your root will be in the top, right? That from that root, we are going to have many branches. A decision tree is drawn upside down with its root at the top. So what is the root here? Is he a male or a female, right? And specifically, I am going to ask a question, is he a male? Because when I ask a decision, I should ask you in such a way that your answer should be yes or no. You cannot have any other answer, right? So my question should be very specific. So I'm asking, is he a male? Is that person a male? If the answer is no, right, now I'm going to have two branches. You can have multiple branches, but a simple decision tree is called as binary decision tree, where we can have only two branches. If it is the answer is no, then the probability of the survival is uh, very. If he is a male, yes, we go for questions. No, then the probability of survival is high. That means the female people, when the Titanic ship was sinking, the women and the children had a higher probability of survival, right? So if it is not a male, then there's a chance the survival is not 100%, but the survival may be high. So all the females will come under that survival category. Again, now in male, my tree doesn't stop. I go for the second feature. Right? If it is a male, then I am asking that if I'm female, no doubt, she is going to survive. Right? Is age greater than 9.5? I'm trying to guess whether that male is a small boy or an adult. Right? If it is greater than 9.5, that means if he is an adult, then again the probability of death is high. Right? All the my left hand side shows yes, my right hand side shows no. Right? So if the age is less than 9.5, then he has a better chance of survival. Again, the next question is how many persons accompanied him? How many persons accompanied him? Is it greater than 2.5? That means around 3 people with him. Then again, the probability of that small boy is also death, because they would have chosen 1 or 2 from each family. If a family has 10 or 12, the chances of having all the 10 or 12 is. So a simple process, once you have the data, once you have the features associated with that, you can draw your own tree. But the question is, what features you should go for, in which order you should have your feature. I cannot have the age first, right? The broader umbrella should come first. That is the first point you have to keep in your mind. And what are the questions I should ask? If you answer these 2 problems, then definitely you can do any application, a cat or a dog, right? Does it has paws? Does it bark? Right? Any questions, and you can easily go for this specific division. So technically speaking, the bold text corresponds to an internal node, right? The first question is a root node. It is called as a root node. But all the age and the number of siblings, the bolded text is called as internal node, right? So based on the internal node, I am going to split into branches or edges. Remember, each node has 2 branches, whether it may be a root node or it may be an internal node. They have 2 branches. So once you will reach a point beyond which you cannot split anymore, right? You have come to a conclusion, whether you have exhausted all your features. That is where features is very important. When you say that I have 5 features or 6 features, then 6 steps will be there. Here I have only 3 features, so I have only 3 steps. So when you come to the last step and you think that, okay, I am done with all my data, then that final node is called as leaf, right? Root, branches, and leaf, right? And from the leaf, you can easily determine when you come in a flow, right? When you come from a path, from the root node till the leaf, you can identify whether that passenger has died or survived. In this normal diagram, it is given in terms of green color for positive and red color for. So all you need to have is data. If you have a data, you can ask some questions and you can go for processing. But the problem here is, as we saw earlier, a real data set will have a lot more features. Right? Here I have taken only 3 features, so it is fine. It looks compact and that's fine. But when you have a lot more features, you will have a very, very big tree. And searching for fruits in a very huge tree is very, very difficult. It is time consuming. Going from the root till the fruit or the leaf is very, very difficult. Right? So what can we do? How can we remodify this algorithm so that the simplicity or the advantages are retained? That is one of the important questions you need to answer. And again, it will also give a clear-cut idea on the importance of features. Right? Age is very, very important. Gender is very, very important. And the number of persons accompanying them is also very, very important. That means for this application, I am treating all other concepts as an irrelevant feature. So features, features, features. When you extract a number of feature, a decisive feature, then the possibility of decision making is high. So this methodology is commonly known as learning decision tree from data, right? Learning decision tree from data. And the diagram which I have shown is called as a classification tree. As I told you, it is to classify whether the person has survived or not. Right? So regression trees also can be used in the same manner. Just they predict a continuous value, as we have seen earlier, like price of a house. So remember, you can make use of this decision tree, right, for both classification and regression. And that's why sometimes when you browse in the internet, this decision tree algorithms are also called as CART algorithm. CART algorithm. C stands for classification, A stands for AND, R stands for regression, and T stands for trees. That means this simple method can be used for classification application and regression application. In short, they call it as CART algorithm. So now we saw the theoretical procedure. Now we will see how this tree is grown and what process are being done in the algorithm part, right? So first thing is you need to grow a tree. You cannot have just the root node. The branches should be formed, and based on the branches, you are going to take a decision. So growing a tree involves deciding on which features to choose, right? Which features to use, age, gender, all these things. But it changes depending on your application. And what condition to use, the question mark, right? Whether it is 9.5, I have given us 9.5 as an age. Say, for example, a small boy. But if you feel 12, a boy with 11-year-old can be also categorized on that, you can have it as 12. So what conditions to use? And along with that, knowing when to stop. So it is not about forming a tree, but knowing all these things when you go for practical implementation. Okay? But as I told you earlier, growing tree is important. Equally important is you need to trim it down, because some trees, some branches will be there in the tree which will not have any fruits or leaves. Right? So the tree may look huge, computational complexity may be there. So in that time, you can go for trimming some of the branches which are not necessary. So I will say your decision tree involves two steps. One is called as tree growing, and the other one is called as tree pruning. Right? Tree pruning. Tree growing or and tree prune. Tree growing means growing the tree, splitting the tree. Tree pruning means cutting it down, cutting it all the unwanted things. So now we will see first about how to go for growing a tree, how to form the branches. You have the complete data set, how you should go for. So in tree growing or the tree splitting method, we consider all the features, and the different split points are tried and tested. Right? You cannot just, when I have a complete data set, you cannot immediately go for checking into different, this is this one or this is the other one. You need to go for categorizing the data based on a trial and error combination. Say, for example, you have a cake. You have a birthday cake before you, right? Now you need to cut that into many pieces and give it to your people who has come for your party. Right? Now, how will you cut? How will you cut? Right? The chocolate wafers may be on the top of the cake. So your aim is you need to cut in such a way that the chocolate wafers will be available for all the people. So how do you cut? So when you cut in such a way that the chocolate, you have fulfilled your objective. That means the error is zero. Right? The error is zero. But we do not know exactly where to cut. So what we do is, in a cake, it is not possible. But in machine learning method, what we are doing is, we are first cutting at a particular point. We are checking whether the error is equal to zero or not. When one piece has a cake piece without any chocolate wafer, then it is wrong. More error. Right? So when I cut into two pieces, the first cut, when I find that chocolate wafers are available in both the pieces, then it is fine. Error is zero. That means even I go for further cuttings, chocolate wafers will be available. Again, you go for cutting the one piece into two again, then that piece into two again, till you go for the end of it. Right? So that is called as cost function. We are going for trial and error method for splitting into different points. And we will choose the split. We will choose the branch, left branch and right branch, when the cost is low. Cost means error. Technically, we can say error. the error is. So now we will see the same example of the Titanic data set. In the first split or the root, right? In the first split or the root, all features are considered. So when I start with the root, I do not know whether I should consider my age as a root, or my gender as a root, or my number of siblings as the root. Right? Now, initially what I do is I cut into many different splits, right? Maybe 3 splits because I have 3 features. Now I will calculate which split or cut is going to give me a low error, or in the sense higher accuracy. We have a mathematical formula that by which we can find out the error for each split or cut, right? A normal branch formation. The split that cost least is chosen. In our example, it is the gender of the passenger. So your first duty is, when you have 3 features, you need to first find out which feature should come in the root node. For that, you go for again splits for the gender, for the age, and then for the number of siblings, and find out which split is going to give you the minimum possible error. So that feature should come in as a top root node. When you have a top root node, then the competition is again with the next 2 features. Again, you go for a cut with them and decide which is giving you a least error, and then you go for making as a second feature. Right? So this is choosing the feature. In the same way, once you have chosen a feature, the cut within the feature is also very important. Right? Say, for example, I'm asking, is he a male or a female? Right? Then the possibility of getting an error is very, very less, because 99% of the time they will be male or female. So no deal in that. But when you go for the age, how do you quantify the age of a small boy? 9.5, 11, or 12. So you need to first split with 9.5 and find out whether he is a small boy. Then 11, then try to find out how many passengers fall in that category. Right? So likewise, when you go for some split, you can find out whether it is 9.5, 11, or 12, for example. So the algorithm is recursive in nature. That means when one root is decided, it is going to be divided into 2, and each internal node, the first node is called as a root node, then we have the internal node, they are going to have some subdivisions, and this algorithm is called as greedy algorithm, because I'm going to keep on dividing my tree into many branches with an objective of minimizing the error, lowering the cost. Now we will see that we have many error functions. A small mathematical equation we see. The error function, the main objective of this cost function is to try to find the most homogeneous branches. So when I say this data is going to divide into male or female, all the males should come under one branch. So that is the point when I can say that my error is equal to 0. When my error is equal to 0, when I cut into 2 branches, when in each branch I have both males and females, then it is heterogeneous. Then I cannot make a decision. When I give another unknown data, it will not be able to make a decision. So when I have a branch, the error function's duty is to make sure that each branch has some homogeneous data only. Right? Because when we go for testing with another data, so when we will follow a specific path, maybe a male, age 9.5 greater or lesser, the number of siblings, and then we will say he's going to survive or die. So homogeneous branches are very, very important. And for a regression application, this is the error formula, right? So for each cut, for each data, your method is going to give you an output, which we are going to call as prediction output. Now, Y is already available output, because you have all the data with you, and you know which person has survived or which person did not survive. So for each internal node, this subtraction, this comparison is being done, and finally they will be added together, and that is called as an error. That means at each node, your error should be minimum to have that specific split. So when to stop splitting, right? When to stop splitting? As we know, we have large set of features. It results in large number of splits also. So more number of splits, more number of branches. More number of branches, the tree structure will look huge, right? So when you have a huge tree structure, you will automatically face overfitting. We saw extensively about overfitting in the previous classes. What do you mean by that? Learning more, looking at the complete branches of the tree and losing the concentration where our data is available. So overfitting is not a good thing. So we need to avoid overfitting. So how we can avoid overfitting? By knowing when to stop, right? When to stop. So one way of doing this is to set a minimum number of training inputs to use on each leaf, right? You cannot have many leaves. If you have many leaves, that means there are many branches, right? So try to categorize your data in the same homogeneous group as much as possible. Try to minimize the number of external leaves, right? If your question is whether this problem is domestic or a wild animal, right? If your application is classification is in domestic and wild animal, don't go for a leaf which will say a difference between dog and a cat, right? There is no meaning in finding whether it is dog or a cat, because your application objective is to find whether it is a domestic animal or a wild animal. Dog and a cat both come under the category of your domestic animal. Say, for example, maybe a parrot and a cat, right? So it is going to come under the category of domestic animals. So look for your application and try to minimize your external leaves as much as possible based on your application. For example, we can use a minimum of 10% just to reach a decision, right? And ignore any leaf that takes less than 10%, right? When I go for classifying as survived or death, when I have only one death possibility, then I can ignore that, because 99% of the time it is going to be only the other case. Then that leaf can be completely removed. So that path will be completely removed. The chances of going to the path is very, very remote. It will not impact my accuracy to higher extent. Another way is to set maximum depth for your model. First one is minimizing the number of leaves. Second one is the maximum depth. Refers to the length of the longest path from a root to a leaf, right? So maximum depth, that means you need to have a longer path. You need to have a longer path. When you have a longer path, it indirectly indicates that all the categories are more or less put into the same group. The possibility of homogeneous group is very high. The number of leaves can be reduced. Right? Shorter paths. When you have shorter paths, that means each branch will end in a leaf. So you have more leaves. So this point and the previous point are interrelated. Minimum number of leaves or maximum depth from the root to the leaf. So once you have grown this tree, now it is your duty that you need to reduce the number of branches, as we have seen, by minimizing the leaves or maximizing the depth. And this performance of tree pruning will definitely increase your accuracy. Right? That same concept. It involves removing the branches that make use of features having low importance. So why I'm saying that leaf is not a specific leaf is not necessary, because that feature or that process or that path is not much important for me. Right? So this way we can reduce the complexity of tree and increase the accuracy, thereby reducing the overfitting. And this process is called as tree pruning, minimizing the number of leaves and also maximizing the depth of your. Pruning can start at either root or the leaves. You can cut from the main root, or you can choose an internal node and find out whether that leaf is necessary or not. You can cut in that way. If you go for cutting the leaves and removing each one, then we call it as a reduced error pruning. And for cutting the leaves, again we have some advanced methods which we call it as cost complexity pruning. So if you are a beginner, I will advise you to go for reduced error pruning. Just look at the leaf, number of data assigned to that leaf. If it is very less, say for example 9, 8 or 5, when you have 300 or 200 data set with you, then you can say that leaf is not necessary. This is the simplest method, but that can be also implemented with some other mathematical formulas, which we call it as a weakest link pruning or cost complexity pruning. That is an advanced form of pruning method. Right? Now we'll see some advantages and disadvantages. Simple to understand. Right? It is very simple to understand, interpret, and visualize. That is the main advantage of CART algorithm. And it implicitly perform variable screening or feature selection. That means when you are removing a leaf, you are indirectly saying that path is not necessary. Right? That means 9.5 age, less or more, that is not necessary. Right? You are giving some weightage to the features. You are selecting the features actually, whether it is important or not important. Can handle both numerical and categorical data. Whenever we talk about numerical data, it falls under regression, and whenever we talk about categorical data, it comes under classification. Can also handle multi-output problems. This is a binary decision tree, but there are also multiple output decision trees. Little effort for a data preparation. You need not do anything much with the data. Once you have the images, the only thing you need to do is splitting into category. Right? Normally, the children when they are playing cards, the playing cards, right? The 52 cards per pack. That game when they play, they normally categorize. Right? These are hearts, these are clubs, and all those things. The same way, right? You are going to split again, and again in that again you are going to split numbers. Jack, king, queen, ace, and something like that. Same process when you are writing a program and forming that, then we call it as a decision tree. So data preparation is very, very less. Noise, if there is a noise also, still I think your decision tree method can give you good answer. Non-linear relationship between parameters do not affect tree performance. Right? Non-linear relationships. Right? That means a jack or a queen, or a jack or a king. Right? We say jack is the son of a king and a queen in the cards, right? But there is no authentication for that. Some games jack has a higher value. In some games, king and queen has a higher value. So it depends. Non-linear relationship. That doesn't matter. We are going to categorize as numbers and images. That's all. So your performance will not be affected that much. But still, we have some disadvantages for this CART algorithm. The first thing is, as we saw earlier, huge tree. Never ever form a huge tree. Maybe when you are growing the tree, you can form a huge tree, but always make sure you prune some of the branches which are not necessary. In your program, when you write your if loop, automatically you can reframe your if loop in such a way that you get only the less number of branches in your tree. Decision trees can be unstable, right? Decision trees can be unstable because small variations in the data might result in a completely different tree, right? When I add some more data, right? Maybe say for example, I am checking for the people survived, male or female. Now, if I include some objects in that a Titanic ship, say for example a diamond or a costly object, also if I put in the data, then I will not know what is my main objective. Right? So I will have a separate branch leaf for the diamond. Right? So when I go for some additional data, even a small variations in the data, my tree will become very, very large. Right? And finally, we may lose the path or the objective why we went for that decision. Right? And this is called as variance, and maybe you can explore much on that as a beginner. That is sufficient for you. And these methods can be, this drawback can be avoided using bagging or boosting methods. And greedy algorithms. So what do you mean by greedy algorithm? You keep on cutting with an intention of making the error value equal to 0. Right? But error cannot be equal to 0 in a real-time situation. So you keep on cutting the cake, right? The best piece, best piece. Finally, when you cut the cake, it may be very, very small. The person may not be able to eat. Right? So make sure that when you have a greedy algorithm, when you cut, make sure you need to stop. You must know when to stop the specific cut, or where the features and the samples are randomly sampled. That you must be always know that. If you follow this procedure, this greedy algorithm effect can be minimized. And decision tree learners create biased trees if some classes dominate, right? If you have a normal and abnormal classification, within normal you will have many branches because the data may be huge. But when you go for abnormal, the data may be less. So you will have only 2 branches. Right? This is called as a biased tree. So whenever you give a testing data, the probability of that data falling under the majority group is high, which may not be exactly correct in all the cases. So you must need to balance your data. Data balancing. Imbalanced data will not work with decision trees. So these are the advantages and disadvantages, right? I have given you an idea of decision tree in a mostly in a theoretical way. That expression you must know, which is for the error calculation. But otherwise, if you have a theoretical understanding, you can further explore to make sure you have some more knowledge in the programming aspect as well as in the mathematical aspect also. Without theoretical understanding, it is very, very difficult to go into that specific concepts. Let me know if you have any doubt. I have never seen anyone asking doubts, right? Asking doubts, it's a good sign because it doesn't mean that you know or you do not know. That is not the question, but you have an eagerness to learn more. Nobody can learn anything, right? Even our machine learning is going to be always iterative in nature, right? We have to learn step by step only. But if you can ask, if you can kindle your thoughts, then that will be much more better. Anyway, let me take the attendance. Amulya. Amulya is there? Okay, absent. Judson.
Sir. Present.
Yes, sir.
Amulya is there?
Yes, sir.
Amulya. Okay. Judson.
Yes, sir.
Samyukta.
Present, sir.
Angel.
Present, sir.
Ajit Pawan.
Yes, sir.
Glory Abhinaya.
Yes, sir.
Kiran Kumar.
Yes, sir.
Manideep.
He has put it in the chat box.
Yes, sir.
Chat box. Okay. Banu Teja.
Sir.
Jennifer. Chat box. Okay.
Chat box, sir.
Okay. Priyadarshini.
Yes, sir.
Jeevan.
Present, sir.
Afreed.
Present, sir.
Jayant.
Jayant mentioned in chat box, sir.
Okay. Vikas. Vikas. Chat box. Vikas absent. Paul Finney.
Present, sir.
Bhuvaneshwar.
Present, sir.
Sumant.
Present, sir.
Ramesh. Chat box. No. Ramesh absent. Neeraj Kumar. Neeraj Kumar absent. Sheikh Zubair.
Present, sir. Neeraj mentioned in chat box, sir.
Neeraj.
Mention in chat box, sir.
Chat box. See if anybody is typing in chat box, kindly let me know because I need to shuffle between the windows. Okay. Neeraj present. Ramesh present. Ramesh absent.
Sir, present, sir.
Ramesh present.
Yes, sir. Present, sir.
Okay. Kirti.
Yes, sir.
Dinesh.
Yes, sir.
Tejaswant.
Yes, sir.
Chat box. No.
Tejas one present, sir.
Madam.
Don't come late, pa. You should be quick. Chandana Priya,
Present, sir.
Karthik,
Yes, sir.
Vijay Kumar,
Yes, sir.
Soman, absent. Janish,
Present, sir.
Rex Vimal,
Yes, sir.
Harshavardhan,
Present, sir.
Uday,
Chat box.
chat box. Sakib,
Present, sir.
Siddharth,
Yes, sir.
Praneeth,
Yes, sir.
Salome,
Yes, sir.
Livingston,
Yes, sir.
Alan,
Yes, sir.
Ronan,
Yes, sir.
Sai Kiran,
Yes, sir.
Joshiba,
Yes, sir.
Shiny,
Yes, sir.
Jasmine,
Yes, sir.
Celestine, Kavya, Jayasuriya,
Yes, sir.
John Paul,
Chat box.
Chat box, sir.
chat box. Manasa,
Yes, sir.
Ashrita,
Present, sir.
Narasimha Reddy,
Yes, sir.
Yes, sir.
Puneet Kumar, Shiny,
Yes, sir. Yes, sir.
chat box. Shiny absent. Shiny is there. Okay. Joshua,
Yes, sir.
Nagakiran, absent. Suraj,
Chat box.
okay, thanks. Monica,
Yes, sir.
Taufik,
Yes, sir.
Manideep,
Present, sir.
Dikshit,
Yes, sir.
Maria Angel, chat box. Okay. Amrut,
Yes, sir.
Pavan Kalyan,
Yes, sir.
Sainath,
Yes, sir.
Gautam,
Yes, sir.
Jagat Chandra,
Present, sir.
Vivekananda,
Yes, sir.
Shashank,
Yes, sir.
Sai Ganesh,
Sir.
Gopi Chand,
Yes, sir.
Ritvik,
Yes, sir.
Solomon Raj,
Yes, sir.
Sudarshan,
Yes, sir.
Sujit Kumar,
Present, sir.
Suresh Kumar, Suresh Kumar absent. Okay. Sunny,
Present, sir.
Amrita Das.
Present, sir.
Okay, I'll read out the absentee's name. Number 39, 88, 138. Who is present?
Present, sir.
39.
Sir, 30.
Name?
Yes, sir. Kenny
What's
Somanjay,
your
sir.
name? Don't
Kenny
come late,
Somanjay,
pa.
sir.
Okay.
No, sir. I came, sir. Network issues, sir.
Okay, all network issue. How can I say network issues for me? Shall I say network issues and switch off and go? How can I do that? 88. Absent is 88 and 138. Okay. Okay, thank you for joining. If you have any queries or doubts, you can ask me at any point of time. Okay, thank you. You can leave the Google Meet.